Exponential functions in 5 minutes. An exponential function is different than a linear function. It doesn't have a constant rate of change, meaning it doesn't increase and decrease by the same amount each time. But an exponential function can increase or decrease. It just doesn't look the same as a linear function. Linear functions show increases and decreases with a negative or positive m value. With an exponential function, it is not going to be a negative value that tells you it's decreasing. But the number inside the parentheses here will tell you if it's growth or decay. All exponential functions have this same format. An initial starting value here, and then the rate of growth or decay as the base to the exponent, whatever the variable may be. The growth can be seen if this b value is greater than 1. If the b value is between 0 and 1, then that would show decay. Here are some examples on the left of exponential growth. Notice the b values are all larger than 1. Here on the right are some examples of decay. Notice these values are all fractional or between 0 and 1. So decay is not negative, but it is a value that is between 0 and 1. And just because you're a fraction doesn't necessarily mean that you're decay. Take an example here where we have 3/2. That's a fraction, but because the fraction is greater than a whole, it is still growth. Whether you use a fractional number or a decimal number, anything between 0 and 1 is decay, and anything greater than 1 is growth. Let's practice identifying the initial value, whether something is growth or decay, and what that growth or decay ratio or factor is. The initial value in this example is 4. This has a rate that is between 0 and 1. Therefore, it is decay. And because the value is 0.5, we call that the decay factor. We are decreasing by 1/2 each time. In this example, the initial value is 6. The base, or the b value, is 2, so that's greater than 1, so this is growth, and the factor is 2. So we begin with the number 6, and we grow by doubling each time. In this example, you'll notice that one of the values is missing. If this is the format of an exponential function, then the value that is the base of the exponent is the rate or growth or decay factor. The number outside multiplying that base would be the initial value. In this case, we only have a b and an x. We don't see any a value in front. That means it must be an invisible 1. Because the base, 3, is higher than 1, this is growth, and the factor is 3. Let's practice graphing some exponential functions. You're asked to graph the exponential function 2 to the power of x. You're then asked to state the domain, the range, and possibly an asymptote. That is the horizontal line in which the exponential function does not pass. Let's open our TI-84 calculator. On the calculator, we're going to enter into the y equals button our exponential function, 2 to the power of x. Now, I'm going to take a look at the table by pressing second graph to view some of the points. You'll notice that some of these decimal points get pretty small, but they never actually become negative. So because these decimal values are pretty lengthy, I'm going to start with something that's reasonable, like -1 and 0.5. So -1 and 0.5. Then 0, 1, 1, 2, 2, 4, 3, 8, and then I'll stop because my little piece of graph has completed. So I'm going to draw a curve here But then you'll notice on my TI-84 that the decimals just keep getting smaller, but they never go underneath that axis line. It hugs it, but it never actually goes underneath it. So be careful when you're drawing here that you don't accidentally get lazy and make that line cross the x-axis like that. Because as seen in the table, it never actually becomes negative. So make sure you hug that axis there, known as the asymptote, when you're graphing. So the y-intercept was 1. The domain is all reals, right? So all reals, left and right, we can go forever infinitely. The range is anything above the x-axis, so that's y equals 0. And the asymptote is also the horizontal line, y is equal to 0. Now I'm going to graph this next one here, 3 1/2 to the x power. So 3 parentheses 1/2 and raised up to the power of x. Again, when I look at my table, I'm going to graph as many points as possible that will fit on my grid. It looks like I'll have -1, 6. Looks like I'll have 0, 3. And it looks like I have 1 and 3/2, or 1 and 1.5. And if I arrow down a little bit here, I'll get 2 and 0.75. And you'll notice it just keeps getting smaller and smaller, but it never actually goes past that axis line. So our y-intercept is 3. Again, our domain is all reals. Our range is greater than 0, and our asymptote line is also 0. And that is how you graph an exponential function.